Welcome to this video on software engineering for web services. In this video, we will explore the basics of software engineering for web services, including what web services are, how they work, and why they are important. Web services are a way for different software applications to communicate with each other over the internet. They allow different systems to exchange data and information, regardless of the programming languages or platforms they are built on. Software engineering for web services involves designing, developing, testing, and maintaining web services that are reliable, scalable, and secure. It requires a deep understanding of web service technologies such as SOAP, REST, and XML, as well as programming languages like Java, Python, and Ruby. In this video, we will cover the following topics: the basics of web services, the different types of web services, the advantages of using web services, the challenges of developing web services, the best practices for designing and developing web services. By the end of this video, you will have a solid understanding of software engineering for web services and how it can help you build better, more reliable, and more scalable web applications. So, let's get started. Before we dive into software engineering for web services, let's first understand the basics of web services. Web services are a set of protocols and standards that allow different software applications to communicate with each other over the internet. They use a client-server architecture, where the client sends a request to the server, and the server responds with the requested data. Web services are built on top of the HTTP protocol, which is the same protocol used by web browsers to communicate with web servers. However, unlike web pages, web services don't return HTML content. Instead, they return data in a format that can be easily consumed by other software applications, such as XML or JSON. There are two main types of web services, SOAP and REST. SOAP Simple Object Access Protocol is a protocol for exchanging structured information in the implementation of web services. It uses XML for its message format and supports a wide range of data types, including complex objects and arrays. SOAP also provides a standardized way of handling errors and security. REST Representational State Transfer is a simpler and more lightweight alternative to SOAP. It uses HTTP methods such as GET, POST, PUT, and delete to perform operations on resources, and returns data in a format that can be easily consumed by other applications, such as JSON or XML. Both SOAP and REST have their own advantages and disadvantages, and the choice between them depends on the specific requirements of the application. In the next segment, we will explore the different types of web services in more detail. Web services can be classified into three main types: SOAP, REST, and XML/RPC. SOAP Simple Object Access Protocol is a protocol for exchanging structured information in the implementation of web services. It uses XML for its message format and supports a wide range of data types, including complex objects and arrays. SOAP also provides a standardized way of handling errors and security. REST Representational State Transfer is a simpler and more lightweight alternative to SOAP. It uses HTTP methods such as GET, POST, PUT, and delete to perform operations on resources, and returns data in a format that can be easily consumed by other applications, such as JSON or XML. XML/RPC XML Remote Procedure Call is a protocol that uses XML to encode its calls and HTTP as a transport mechanism. It is a simpler and more lightweight alternative to SOAP, but it has limited support for data types and error handling. Each type of web service has its own advantages and disadvantages, and the choice between them depends on the specific requirements of the application. SOAP is best suited for applications that require complex data types and error handling, and where security is a major concern. REST is best suited for applications that require simple data types and where performance is a major concern. XML/RPC is best suited for applications that require a simple and lightweight protocol. Then the next segment, we will explore the advantages of using web services. Web services offer several advantages over traditional software applications. Here are some of the key advantages. 1. Interoperability. Web services allow different software applications to communicate with each other, regardless of the programming languages or platforms they are built on. This makes it easier to integrate different systems and share data between them. 2. Scalability. Web services can be easily scaled up or down to meet the changing demands of the application. This makes it easier to handle large volumes of data and traffic. 3. Reusability. Web services can be reused across different applications, which reduces development time and costs. This also makes it easier to maintain and update the application. 4. Security. Web services provide a standardized way of handling security, such as authentication and encryption. This makes it easier to secure the application and protect sensitive data. 5. Cost-effective. Web services are often more cost-effective than traditional software applications, as they require less hardware and infrastructure. 6. Platform independence. Web services can be accessed from any platform or device that has an internet connection, which makes them more accessible to users. Overall, web services offer a more flexible, scalable, and cost-effective way of building software applications. In the next segment, we will explore the challenges of developing web services. While web services offer many advantages, they also come with their own set of challenges. Here are some of the key challenges of developing web services. 1. Complexity. Web services can be complex to design, develop, and maintain, especially when dealing with large volumes of data and traffic. 2. Compatibility. Web services need to be compatible with different platforms, programming languages, and versions. This can make it difficult to ensure compatibility across different systems. 3. Security. Web services need to be secure as they often handle sensitive data. This requires a deep understanding of security protocols and best practices. 4. Performance. Web services need to be fast and responsive, especially when handling large volumes of data and traffic. This requires careful optimization and testing. 5. Testing. Web services need to be thoroughly tested to ensure they are reliable and scalable. This requires a deep understanding of testing methodologies and tools. Despite these challenges, web services offer many benefits and are becoming increasingly popular in the development of software applications. By following best practices and using the right tools and technologies, developers can overcome these challenges and build robust and scalable web services. Thank you for watching this video on software engineering for web services. We hope you found it informative and useful. If you have any questions or comments, please leave them below.